Hey, Algebra 1, Saxon Math. We're looking at lesson 16, and we're going to be talking about simplifying and evaluating variable expressions. So when we talk about evaluating expressions, basically what we're referring to is substituting values into an expression and then evaluating it. Whenever you see the word evaluate, it really does mean you're looking for a numerical answer. So we see that we have an A in this expression and the variable P, and then we're given the definition of what they are, or a value for each. A is equal to 3 and P is equal to 4. So we're going to rewrite this whole thing with A being 3 and P being 4. Negative 3, open parentheses, even though it's a bracket, it's like a parentheses, minus 3 right there, open parentheses, 4 minus 3, close parentheses, and close bracket. So now this is the situation. We're going to go in, we're going to use order of operations. We're going to do what's inside the parentheses first. So what we end up with is 4 minus 3, which is 1. And watch how I just write everything back down to give myself a little bit of perspective. I just changed one thing. Now I'm going to deal with what's inside of the brackets. The brackets are kind of like parentheses too. So negative 3 times 1 needs to be done before I deal with this guy. Negative 3 times 1 is negative 3, and that's what's here in the bracket, and I'm done. And finally, negative 3 times negative 3 is 9, positive 9, and that's the answer. Make sense? Hopefully so. We're going to do part B. Let's see what we got. Let's scooch this down a bit. We get 9, and here's part B. Let me give us some space. Let's give us some space. Okay, so B is asking us to evaluate, but we have some different values here. Now we're dealing with X and A. Notice that A is a different value than it was in the problem before. Hence the name for these letters, they are variables because they vary. They can change from problem to problem, right? Not in the same problem, but from problem to problem, our variable can be different. So this is confusing me. I'm just going to draw a line to keep my brain focused over here. So I'm going to plug in negative 2 and 7 for X and A. So negative 7, right, because negative X, plus negative 2 minus the quantity of 7 minus negative 2. Okay, take a moment, make sure we only replace X with 7 and A with negative 2, and then we're going to keep it moving. Negative 7 plus a negative 2, we're doing what's in the parentheses first, is going to give us a negative 9. So we get negative 9 minus whatever this is. 7 minus a minus 2, keep change. We're going to get 7 plus a positive 2. And then so what that is, we're going to get a 9 here. So we end up with negative 9 minus 9. Hopefully you know that this is negative 18, okay? So negative 9 minus 9, you could keep change this if you're still working on that skill, and you would see that it's a negative 18, and the text agrees. Let's look at the next example. So in example 2, we're now evaluating an expression with 3 variables. And so we have in part A here, yx, and then zyx, and we're multiplying all this stuff together. We see that x is equal to 2, y is equal to negative 1, and z is equal to 4. So let's plug it in. Let's see what we got. Negative 1 times 2, just replacing those guys. And then I'm going to get z, which is 4 times negative 1 times 2. And honestly, multiplication, the parentheses, it's all being multiplied. So we can just multiply everything together if we wanted to. However, let's go ahead and go in order. This is negative 2. 4 times negative 1 is negative 4. Times 2 is going to give me a negative 8. Pause me if I'm talking too fast because it happens sometimes. Then our final answer is a positive 16. So that's part A. Positive 16 is what we get. Let's see what we have for part B. Part B, our expression is a little bit more involved. So we've got like a little fraction action. So let's go ahead and see how that plays out. So in part B, we've got x times the quantity of 4AP, all of that over xp. I'm not even going to lie. I would want to simplify this first. A equals 1, P equals 5, and x equals negative 3. Since I see the x here and the x here and the p here and the p here, I almost think that they're irrelevant, but let's go ahead and play out and see how it works out. So x, let's go ahead and substitute negative 3 in for x. 4 times a, which is 1, times p, which is 5. So that's the numerator. The denominator is going to be negative 3 times P, which is 5. So if we were to multiply it out, like I said, I kind of feel like canceling stuff out. Looks like the answers are going to be 4. Can you see it? Cancel, 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 cancel. And then we got 4 times 1. But let's see if it works out if we multiply. Here in the numerator, we get, let's see, 4 times 5 is 20, times 1, that's all 20. 20 times a negative 3 is a negative 60. And so in the denominator, we get a negative 15. And just as we suspected, negative 60 divided by negative 15 is a positive 4. I'm interested in seeing how the text did it. Nope, they did it the same way. Multiply, multiply, multiply. All right, we could have done some canceling here, but we'll get to that as we get more in depth in our mathematical understanding. All right, so that brings us to example C. So they're asking us, okay, so here's the deal. We're going to simplify before we evaluate. So what that means is we're going to make the expression look a little bit less intimidating before we actually evaluate. So here's our expression. X is equal to 0.5 and y is equal to negative 1.75. So how can we simplify this? We could use the distributive property, see if that makes our life simpler. I guess we could do that. So instead of we could distribute. I don't know what they want us to do. I don't know. Now I'm actually not sure. Let's try it. Let's distribute through. So this goes here, this goes here. So when I do that, I get a negative xy plus 3x. Do you see that? A negative times a negative is a positive. Positive 3x plus y. And now I can plug everything in. I want to take a sneak peek and see if that's what they did. They did do that. I don't know if that makes my life happier, but whatever. So, all right, cool. So we're going to take our 0.5. We're going to multiply it, our negative 0.5, sorry, negative x, so negative 0.5. We're going to multiply it by negative 1.75 plus 3 times 0.5. And then we're going to add to that a negative 1.75. So, okay, after some little math cheating, we multiplied these together, multiplied these, added it all up, and our answer is 0.625. Awesome, awesome, awesome. So we get to part B, and part B has fractions, which feels intimidating, but I think we can handle it. We're dealing with x times x plus 2y minus x, and so we're going to simplify distributive property. We got x squared plus 2yx, or 2xy. I'll write it like that just because of order. We generally write it in alphabetical order. X squared plus 2xy minus x, recognizing that x is equal to 1/2 and y is equal to 1/4. We're just going to plug it in. So x squared will now be 1/2 quantity squared plus 2 times 1/2 times 1/4. And then we're going to subtract 1/2 from that. All right, you can check and make sure that makes sense before you start calculating. So I'm just going to deal with the exponent first, deal with some multiplication going across. 2 times 1/2 is actually 1. So I'm left with 1/4 here when I multiply that all together, because 2 times 1/2 is 1, 1 times 1/4 is 1, and then I'm going to subtract 1/2. 1/4 and 1/4 is 2/4 minus 1/2, and of course we know 2/4 can be written as 1/2 minus 1/2. All that work just to come up with nothing. All right, so we end up with 0 at the end of that problem. So here we are in example 4, and we are going to evaluate the expression. We're told that m is equal to negative 2, so it's a lot more substitution. Y is equal to 2.5, and we get the pleasure of calculating or figuring out what y times m to the third power is. Y being 2.5, we're going to put it there. M to the third power, we'll take that negative 2, raise it to the third. Let's deal with the exponent first. We get 8. Negative 8, that is, when I take negative 2 times negative 2 times negative 2, then I'm going to multiply that by 2.5. So I know my final answer is going to be negative. 8 times 2 is 16, and then 8 times 1/2 is 4. 16 and 4 is 20. My answer is negative 20 for part A. Let's see, did they agree? They agreed. Okay, cool. So let's go ahead and take a look at this next one, part B. And the process of doing this is going to be similar. Let's go ahead and get our substitution in. We've got 2 times the quantity of A over 5 minus B, but we're taking the square of all of that. So let's see how that works out. We know that A is equal to 3 and B is equal to -1. Plugging everything in, we get 2 times the quantity of 3 over 5 minus a -1. And we're going to square that. Let's simplify what's going on in the parentheses there. So coming back to the parentheses, we have 3 over 5 minus a -1 is actually 6, right? 5 plus 1, keep, change, quantity squared. Still dealing with simplifying what's inside of the parentheses. That's going to be 1/2. And now we've got 2 times 1/2 times 1/2, which is 1/4. So when I multiply 2 times 1/4, I get 2 over 4, which we already know is just 1/2. So if we did this right, our answer should agree with the textbook and we should get 1/2 as our final answer. Scooch, 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 boom, we did it. We're awesome. Let's take a look at the next one. All right, this is our final example, but it is kind of complicated when you read it, but then when you look at it, it's going to be simple. So let's take a look. We're given a formula that's going to talk about interest as it accumulates in an account. P sub y is just a variable that refers to the amount of money you have in a particular year. So the amount of money you have in a particular year is equal to 1.04 times the amount of money you had in the year before, which is P sub y minus 1. So for instance, if I wanted to know how much money I had at year 5, I'd have to take 1.04 and multiply it by how much money I had at year 4. Does that make sense? Okay, so if that's the case, I love my children. If that's the case, what we're going to do is use that information to answer the question here. So the question says, after 6 years, there is a principal balance of $1,450. So P sub 6 is equal to $1,450, right? They're asking us how much is in that account after 8 years if nothing changes and we keep with this process. So P sub 8 is the question that we're looking for. So P sub 8 requires that we multiply what happened the year before, P sub 7, with 1.04. Pause me and think about it if this kind of makes sense, all right? And if it doesn't, let me know. We can talk about it. So P sub 8 is equal to 1.04 times P sub 7, but we don't have P sub 8. We got P sub 6. I wish we could find, we don't have P sub 7, rather, we have P sub 6. And we can find P sub 7. We can take P sub 7 and find it by multiplying P sub 6, the thing that happened the year before, by 1.04. So what we're going to do is first find this value. We'll find P sub 7, make it a little bit smaller. We'll find that. Well, let's put it over here. We'll find that, and then we'll use that information right there to plug it into this, and then we'll find P sub 8. Easy peasy, lemon squeezy. Let's see. 1.04. So to find P sub 7, we know we're going to take 1,450, which is P sub 6, and multiply it by 1.04. By the magic of pausing, the answer is 1,508. So now we're going to take P sub 7, plug it in here, and figure out what P sub 8 is. So the equation would look like this. P sub 8, I guess I can just write it here. P sub 8 is equal to 1.04 times 1,508. And again, the magic of pausing, $1,568.32. All right. So that's the process. Take a look at it. Ask me about it because it was a little complicated. And they explain it slightly differently, but basically the same way in the text. Please feel free to do everything here in the lesson practice and go on and do the practice odd ones, and make sure you read over the even ones. Take care. Talk to you soon. Bye-bye.